Hi, good evening. This is Manohar. In last class, we have seen chemical kinetics part 2. Today, I am going to introduce chemical kinetics part 3. In this chemical kinetics part 3, I am going to explain zero order reaction and some silent features of zero order reaction and relative aspects of zero order reaction. Now, I am going to discuss with you. And at the end of the video, I am going to give some beautiful tips to you. Please watch continuously this video till the end. So, zero order reaction. The reaction in which reactions the rate does not depend on the concentration of the reactants, we call it as zero order reactions. So when we are taking one hypothetical chemical equation, rate A gives product. So for this I am taking rate is directly proportional to concentration of A. So minus dA by dt, change in concentration of reactant with respect to time, is equal to K into A to the power of 0. Why? Because this is zero order reaction. So that dA by dt is equal to something to the power 1. So then after minus dA is equal to K into dt. Now take integration on both sides. Take integration on both sides, then you will get like this. So integration of dA is equal to integration of K into dt. So integration of dA is nothing but A is equal to K is constant here, so integration of dt is equal to T minus A is equal to K into T. After that integral constant I naught. So I naught we call it as integral constant. To know the value of integral constant, we have to take like this. When t is equal to 0, then A will become what? A naught. When t is equal to 0, time value is 0, then the concentration we call it as initial concentration, right? Then you substitute these two values in equation 1, then you will get minus A naught is equal to K into 0 plus I naught. Then I naught value is equal to A naught. Then you substitute this value in equation 1, then you will get this type of equation. Minus A is equal to K1 K into T and minus A naught you will get. So to take minus A naught this left hand side, then you will get A naught minus A is equal to K naught into T. This is K naught, zero order rate constant. So that K naught is equal to, finally K naught is equal to A naught minus A by upon T. So that A naught is nothing but initial concentration. So initial concentration minus final concentration. Initial concentration minus final concentration with respect to time, we call it as what? Zero order integral rate equation. So far whatever we discussed is nothing but zero order integral equation, rate equation. Minus x dA is equal to what? Integration of 0 to t. For time intervals are there, as well as initial concentration also having two intervals. So in such case, which equation will come? Now we are going to calculate that. So integration of A is integration of A means A, so that lower limit is A naught and upper limit is A naught minus x is equal to, for this, K naught into integration of t, kt dt is nothing but t will come. So t, upper limit is t and lower limit is 0. So when you substitute this upper limit and lower limit, so in place of this thing you have to substitute upper limit, then after lower limit. So A naught minus x, so minus here A naught minus x minus A naught is equal to K naught into t will come, t minus 0, right? So minus of A naught minus x minus plus A naught minus x minus A naught is equal to K naught into t, right? So here minus of A naught minus x minus A naught is equal to K naught into t. A naught get cancelled, minus into minus plus. So x is equal to K naught into t. So t is equal to x by K naught will come. This is also one of the expression for the zero order rate equation, integral rate equation. And one more equation also is there in some reference books like this. What is meant by half-life actually? So how much time is required to complete 50% of initial concentration is called half-life of a reaction. If reactants are 100% are there, in that 100% to complete 50% of the reactant concentration, how much time is required is called T of or half-life of a reaction. right? So that now we are going to discuss the half-life of the zero order reaction, right? So half-life time should be half of the initial concentration, then we call it as what? Half-life time. So just now we discussed x is equal k is equal to k naught is equal to what? X by t will come, right? So this is called initial concentration. So that final concentration should be half of initial concentration, or in this x percentage, to complete half percentage of x, how much time is required? We call it as what? Half-life time. So k naught is equal to x by 2 into k, sorry, x by 2 into t of will come. So t of is equal to k naught is equal to x by 2 into t of, we need t of, so t of is equal to x by 2 into k naught will come. So this is the relation between half-life time and initial concentration of the reactant. Here you take t of is directly proportional to initial concentration. Why? Because here 1 by 2 k naught is constant, so that t of is directly proportional to a naught. So based on this one, how there is a chance to ask different types of questions. So here you see t of first instant by t of a second instant is equal to what? A1 by A2. When there is a chance to ask, they will provide you t1 value, t of 1 value and a0 value, and this also they will provide. When they provide these three values, then you can calculate by using this relation, then you calculate its concentration. This is one of the important concept which is related with the half-life time. For example, you see one question I am giving to you people. So example, so for a reaction half-life time is 250 second. Half-life time is 250 second. Then initial concentration means a value is doubled, initial concentration is doubled. Then what is the value of t of? Then what is the value of t of? So just now I told you I will give some tricks to solve this type of problems. So based on this trick, you can solve this problem within fraction of seconds. So what is the relation here? T of 1 is directly proportional to a, means here how many t ofs they given? So half-life time is what? 250 seconds when initial concentration is a. So t of first is equal to what? A1, right? In case of second one, t of second is equal to what? A2 concentrations, right? So A1 value is nothing but A only. They are changing this concentration twice of this one. So means instead of A2, you have to write what? 2A1. So first half-life time is how much? 250 seconds. So instead of t of 1, you substitute just 250, right? A get cancelled. 250 into 2 is nothing but what? 500 seconds. So answer is 500 seconds. Within 5 seconds, you can answer this type of tricks. When you are using this type of tricks, we can solve very easily. Comparing with traditional method, this method is the best for competitive exams. I hope you understand, right? So then after pause the answer. Here you see that is initial concentration. A0 is initial concentration. So A0 minus X means final concentration. Right? So X means consumption of reactants. Consumption of reactants. How much percentage of reactant consumed or involved in a reaction can be predicted by using X, right? So why I am saying all these things means, so you go for zero order rate equation. So that is K naught is equal to what? X by T is there. So what does it mean? So with respect to this time, this much concentration will be decreased with respect to reactants. That this gives that information only, no? Means with respect to this time, this much reactants are involving in a reaction. So now I am expressing like this. So K naught is equal to X into Tx percentage. What does it mean? So with respect to this time, X percent is consumed. So that I am taking like this. So Tx percentage is equal to what? X by K naught. So now I am taking Y percentage. So K naught is equal to Y by what? Ty percentage. Then Ty percentage is equal to what? Y by what? K naught will come. Y by K naught. So now the relation between these two equations, the relation between this equation 1 and equation 2, right? So Tx percentage is equal to x by k naught and Ty percentage is equal to y by k naught. So equation 1 divided by equation 2, so then k naught get cancelled. So Tx percentage by Ty percentage is nothing but what? X by y. So this relation is very important. Now I am going to give one practice question based on this formula, right? So one more thing, T50% is there. T50%, what is the relation between T50% and T75% in case of a zero order reaction? So T50 means T of, we can say. T75 means, so 3 by 4th part of completion of the reaction. How much time will be required to complete 3 by 4 part of a reaction? We call it as what? T75%. So this will be, this we can solve by using this equation. Tx percentage and Ty percentage means T50 by what? T75. So 50 means how much it will be? So 50 is nothing but what? 50% it will be completed and it is 75. 25 2 ja, 25 3 ja. So that T50 by T75 is equal to what? 2 by 3 will come, right? So we need T50. So T50 is equal to, or T75 is equal to, T75 is equal to 2 by 3 into, 3 by 2 into what? T50. Right, this is also one of the important relation in between T75 and T off. So you see here T50 and T75, here 2 by 3 will come. So we need T75 so that this value will come this side, so that it will 2 by 3 will become what? 3 by 2. So based on this relation, how they will create question, you see, very interesting question here, very interesting and very funny questions, right? So one reaction is there, it will be completed. So A2 75% means to complete A2 product 1 reaction is there. In this 75% will be completed in 3 seconds. This reaction 75% completed in 3 seconds. Then they are expecting T of this reaction to complete 50% of this reaction. How much time will takes place? You see, T75 will be completed in 3 seconds. So T50% will be completed in how much? Means 75% will be completed in 3 seconds. Then at what time T50% will be completed? So this relation we can use here. What they given here? T75. They given T75. T75 is nothing but how much? 3 seconds here. So is equal to 3 by 2 into what? T off. So 3 get cancelled. So T off is equal to what? 2 seconds. So that T off will be completed in 2 seconds. So means to complete 50% of a reaction, you require how many seconds? 2 seconds. By using this trick only we can solve. This is easy, okay? Of zero order reaction, graphical representation. So you see, rate equation is nothing but what? Here rate equation will be like this. So K naught is equal to what? X by T. So X is equal to what? K naught into T. So this is in the form of what? Y is equal to mx. So that the graph will become like this. So on this I am taking concentration. Here what? Concentration and time. Concentration and time, then graph will become like this. So y is equal to mx. So when I am taking one more equation, k is equal to what? A naught minus a, initial concentration minus final concentration by t. So kt is equal to what? A naught minus a. So that a is equal to what? A naught minus kt. A is equal to a naught minus kt. So this is in the form of what? Y is equal to mx plus c. Y is equal to, this is in the form of y is equal to mx plus c. So here intercept is a naught, negative slope is there. So that the equation will be like this. Y is equal to mx plus c, curve will be like this. So here I am taking concentration, here I am taking time. So here negative slope will come. Slope. Here slope we can calculate like this. Slope is negative here. So this is two graphs are there, and one more graph also is available for the zero order reaction. So according to zero order reaction, rate is equal to k. Right, rate is equal to k means rate value will be constant, right? So rate with respect to here rate I am taking, here time I am taking, right? So rate and time value will be constant like this. Rate will be constant with respect to time. So right. So these are the different types of graphs, and T of versus A. One more graph is there, T of versus A. So T of is directly proportional to A. So T of is equal to what? K into A. So that this is in the form of y is equal to mx. So I am taking on y axis T of, and here initial concentration. So the graph will be come like this. So here slope is positive slope. So these are the different types of graphs related with the zero order. And units I told you already, mole to the power of 1 minus n, mole to the power of 1 minus n, liter to the power of n minus 1, and second to the power of minus 1. So this is zero order reaction, so that you have to substitute instead of n 0. So that's mole to the power of 1 and liter to the power of minus 1 and second to the power of minus 1. These are the units of what? Zero order rate constant, right? Up and down. Which reactions will come under zero order rate equation, right? So first one is photochemical reactions. First one is photochemical reactions. Photochemical reaction means H2 plus Cl2 gives rise to HCl. So it does not depend on the hydrogen concentration and chlorine concentration. It will depend only on intensity of light. So second example is decomposition of nitrogen. Decomposition of N2O, nitrous oxide. So that N2O decompose on gold surface, gold. So N2 plus half O2, right? So then after decomposition of ammonia, decomposition of ammonia. So on molybdenum surface, decomposition of ammonia on molybdenum surface, 2NH3 will gives N2 plus 3H2 on molybdenum surface. And one more example for the zero order reaction is iodination of acetone. Iodination of acetone. So that's CH3 C double bond O CH3 plus I2 in presence of H plus. In presence of H plus, it will give I CH2 C double bond O CH3 plus HI. So here rate we can express like this. Rate is directly proportional to CH3 C double bond O CH3 and H plus concentration, but it does not depends on iodine concentration. With respect to iodine, this is zero order reaction, not with respect to overall, right? And one more example for this is enzyme catalyzed reactions. Enzyme catalyzed reactions will come under what? Zero order reactions. Enzyme catalyzed reactions will come under zero order reactions. So this is complete information regarding zero orders. I will come with new topic again. Thank you. Please subscribe my channel.